morning students. Today we are going to discuss about significant figures, rounding off, and the last one, arithmetical operations with significant figures. Now we will see significant figures. So significant figures or significant digits. So what is significant figure? Number of meaningful digits in a measurement is called significant figures. So significant figures can be used to know how precise the answer is or how much uncertainty there is. For example, you take these two numbers. In this 1.15, the first two digits, as well as in this number, the first two digits, how it is? They are reliable digits. They are reliable digits. Because here it is 1.1, then also it is 1.1. But if we see the second one, this 5 and this 7, there are uncertainty. So I can call it as first uncertainty. They are not same. So now I can define significant figures. Sum of these reliable digits and first uncertainty is called significant figures. Clear? Now we are going to rules for counting significant figures. The rules for counting significant figures. Okay. First rule. So in this number there is no zero. It is non-zero digits. So here I have given non-zero digits. If there is non-zero digits, then we must count all the digits. That will give the significant figure. In this number, that is the first rule. In this number, so you count how many digits are there? 1, 2, 3, 4, 5. So the significant figures for this number is 5. Clear? Second rule is in this number 0 is in between two non-digits. The 0 is in between two non-digits. Then you must count all the digits. That will give the significant figure. So 1, 2, 3. So the significant figure is 3. Here also the significant figure is 3. This is second rule. Third rule. Now you consider this number. So 3400 decimal point. Here 2 non-zero digits followed by 0 digits with decimal. Here 2 non-zero digits followed by zeros with decimal. In that case, you must include all the digits. So here what will be the significant figure? 1, 2, 3, 4. The significant figure is 4. Clear? Next rule. In this number, what will be the significant figure? Here, before non-zero digits, if zeros are there, that is preceding zeros, then it should be excluded. It should not be counted. Now you count remaining things. 1, 2, 3. So for this number, the significant figure will be 3. Next rule. Now you see in this example, after non-zero digit, all zeros are there. That means terminal places are zeros. In that case, you must exclude these zeros and then count. So what will be the significant figure for this? 1, 2, 3. But if any units you are writing along with the numbers, then in that case you must include that 0 also. So here what will be the significant figures? 1, 2, 3, 4, 5. Clear? Next, sixth one. What will be the significant figure for this? After decimal, zeros are there, and then before decimal, zeros are there. In that case, you must include all the digits. So here 1, 2, 3, 4. So 4 will be the significant figure for this number. Now if you go for this example, this one is what preceding with non-zero digits. So it will be excluded. But these two zeros are included. So 1, 2, 3, 4. Here 4 will be the significant figures. Clear? Next we will go for seventh one. Now this 2.303 centimeter. Now you convert this value into millimeter. This one is multiplication, long means division. So I want to convert centimeter into millimeter. So multiply. So it becomes what? 23.03 millimeter. Suppose if I want to convert this centimeter into meter, so downwards, so divide. So it becomes 0.02303 meter. So in this number, what will be the significant figure? 1, 2, 3, 4. Here 1, 2, 3, 4. In this number, it is excluded. So 1, 2, 3, 4. Now you see all these values. Here the significant figures are same, even though there is a change in the unit. That will use a seventh row. Clear? Now, we take an example. The circumference of a circle. What is the formula? 2 pi r. The circumference of a circle is 2 pi r. What will be the significant figure for this? Now we will check it. 2. What is the value of pi? 22 by 7. R will be 7. It cancels. So we will be getting what? 44. So what will be the significant figure for this? We will tell us what? We will be getting it as 2 digits. But it is wrong. It is wrong. So why? In the sense, this value is 2 pi r. Here it is an infinite significant figure. It is an infinite significant figures. Why it is infinite significant figures? So this 2 can be written as 2, 2.0, 2.00, like it infinite number of times. That is zeros added. So here, what will be the significant figure for this? 1. Significant figure 2. Here it will be 3 1. So it goes up to infinite. So only we are calling this 2 pi r is an infinite significant figures. Clear? Next example. Now you take this number. Here, what will be the significant figures? So I will be writing this as 3 considered in the significant figures. I think it is clear. All these 7 rules in your textbook, it is given in the page number 28. In page number 28, if you go through all the 7 rules, it has been explained. Now, we will see an example that is given in my book, page number 27. That is example 1.10. State the number of significant figures in the following. You see the first number. What will be the significant figure for this? Here, the terminal places are zeros. That means it should be excluded. Can I exclude these 2 zeros? Can't, because in between 2 non-zero digits. In between 2 non-zero digits means it should be included. So 1, 2, 3, 4. So 4 significant figures. For 400, terminal places zeros excluded. So 1. Significant figure for this is 1. Now here, preceding to non-zero digits are excluded. So left is 1. So you will be the significant figure for this is 1. Now in this, what will be the significant figure? The decimal point is there. So this 0 should be included. So 1, 2, 3, 4, 5. Clear? Next, in this number, what will be the significant figures? This part should be excluded. So totally 1, 2, 3. So 3 significant digits for this number. Here if you see this one, preceding to non-zero digits, zeros are there. So it should be excluded. This 0 will be included because it is in between 2 non-zero digits. So totally 1, 2, 3, 4. 4 significant figures. Clear? Now here I have given some numbers. You calculate the significant figures for all these numbers and submit it today itself. You consider this one as a homework. Now we will see rounding off. So rounding off means the result of calculation with numbers which contain more than one uncertain digit. More than one uncertain digit should be rounded off. For rounding off, there are some rules to be followed. Let us see. We are going to see up to 3 digits. Up to 3 digits. Now, these are the rules. Up to 3 digits. If it is less than 5, then the preceding digit you must write as it is. Suppose if it is greater than 5, the preceding digit you must add 1. If it is equal to 5 and the previous digit is even, then you must write as it is. If it is equal to 5 and the previous digit is odd, then you must add 1. Now, I will be explaining clearly with the help of example. Now, for this, 1, 2, 3, 4. Now, question is up to 3 digits. So, up to 3 digits. The fourth digit should be dropped. It should be dropped. You check the rule here. This fourth digit is 4 and it is less than 5. Then means how to round up this one? I must write as it is. The previous digit I should write as it is. So 1.23. Clear? So 1.234. I should round up to 3 digits. Okay. Then we see the fourth digit that should be dropped. So the fourth digit is less than 5. So I should write as it is this 1.23. Clear? Now go for second rule. 1.268. Here my question is up to 3 digits. You see the fourth digit, it is greater than 5. That means the preceding digit you must add 1. So that one 1.3457. Here up to 3 digits. The fourth digit should be dropped and that is equal to 5 followed by the digits. Followed by the digit. In that case, the previous digit you must add 1. Therefore 1.35. Next example and the next rule is 1.345. I should round up to 3 digits. The last digit is equal to 5. The last digit is equal to 5 and the previous digit it is even. Then I should write as it is. Or so up to 3 digits. 5 should be dropped, but it should be what happened? Followed by 0. In that case, and if the digit, the previous digit is even, in that case also you must write as it is. Clear? Next one. You see here, up to 3 digits, it is equal to 5, and the previous digit is what? Odd. Then you must add 1. Or 1.3150. 5 followed by 0. In that case also we must add 1 to the previous digit. It is clear. Next we will go for example 1.11, page number 27. Rounding out the following the numbers as indicated. 18.35 up to 3 digits. Up to 3 digits. The reward, the fourth digit should be dropped. It is equal to 5. You see the previous one, odd. Odd means add 1. So it is 18.4. Clear? Next, up to 3 digits. 5, that is equal to 5. Previous digit, even. Then I should write as it is. So 19.4. Here, up to 4 digits. Last digit is what? 5. That should be dropped. 5. Previous digit odd. That means we must add 1. So 101.6 into 10 power 6. Up to 3 digits. The whole number means we must write at 3 digits and followed by zeros. Followed by zeros. Next, up to 3 digits. 5. Followed by the digit. Followed by the digit means what? Right. Followed by digit. We must add 1 to the previous. So I write as 12.7. It is clear. Now we will see arithmetic operations with the significant figures. So what are all arithmetic operators? Addition, subtraction, multiplication, and division. Okay, for addition and and subtraction, we should consider least decimal places. Least decimal places. For addition and subtraction, we should consider least decimal places, and for multiplication and division, we should consider least significant figures. Least significant figures. Here, for example, if I take addition, (1.3 plus 1.25 plus 1.327). In this, what is the decimal here? Only one, first decimal. There is one decimal here. Here, half decimal 2, so 2 decimal. Here, half decimal 3 digits, so here 3 decimal. Okay, now to add this one, 1.3, 1.25, 1.327. So 3.877. The least decimal places is what? 1. So which digit I should drop? This 7 I should drop it. Now you check the rule. The 7 is greater than 5. 7 is greater than 5. That means you must add 1. So my answer is what now? 3.9. You must add 1 to the preceding digit. Clear? Now we will go for subtraction. (1.32 minus 1.214). Here, after decimal how many digits? 2. So 2. Here, 3 decimal places. Now you subtract this value. 1.32, 1.214. Okay. Now you see up to how many decimal places here? The least one, 2. So after decimal, up to this I should consider. So see the last digit 6. It is greater than 5. If it is greater than 5 means plus 1 to be added. So to the previous one. So my answer is 1.11. Clear? Next we will go for multiplication. Multiplication means least significant figures. So 1.12 into 1.141. Here the least significant figure is what? 3. Here the least significant figure is 4. Here the significant figure is 3. Here the significant figure is 4. Now you multiply these two values. Now my thing is rounding off. Okay. Here the least significant figure is what? 3. That means up to 3 I should take. This number, this digit should be dropped. If I want to drop this digit, we check the rule here. It is greater than 5. That means I should add 1 to the previous digit. So my answer is 1.28. Clear? Now we will go for division. Here how many significant figure? 4. Here how many significant figure? 2. Now you divide this one. So I am getting 30.6. So the least significant figure is what? 2. See the next digit? 6. It is greater than 5. So you must add 1 to the previous digit. That means my answer is 31. I think it is clear. So now we will see the numerical problem. It is problem number 4, question number 2. It is in page number 39. The radius of the circle is 3.12 centimeter. Calculate the area of the circle with regard to significant figures. So now this is the circle. Radius is 3.12 meter and they ask to find out area. So what is given? Radius. How much? 3.12 meter. What they ask to find? Area of the circle. Solution. What is the formula for area of the circle? Pi or square. So pi value 3.14. What is our value? 3.12 into 3.12. If I multiply this, I will be getting the value as 30.566 meter square. Clear? But they ask the answer to be in significant figures. Now, for significant figures, to find out the significant figures for multiplication, the least significant figures you must take. Here what are the significant figures? 3. Here 3. Here also 3. So the least significant figure is 3. Now this figure should be dropped out. This digit is greater than 5. If it is greater than 5, 1 must be added to the previous digit. So therefore it becomes 30.6 meter square. Understood?